Good morning everyone. I am Santillan John David D from H2B. This is the subject of Meteorology 211. This is our final project. So we are to make a video of ourselves and we tell you what we have learned from our topic from week 1 to week 4 of this subject. So I've learned from week 1 is anticyclone. An anticyclone is opposite to cyclone is a weather phenomenon defined as a large-scale circulation of winds around the central region of high atmospheric pressure, clockwise in the northern hemisphere and northern hemisphere, and counterclockwise in the southern hemisphere. Effects of surface-based anticyclones include clearing skies as well as cooler, drier air. So, I learned from a ridge or a barometric ridge. It's a term of meteorology describing an elongated area of relatively high atmospheric pressure compared to the surrounding environment, without being close circulation. It is based and associated with an area of maximum anticyclonic curvature of wind flow. The ridge originates in the center of anticyclone and sandwiched between two low pressure areas, and the focus on the maximum curvature is called ridge line. This phenomenon is the opposite of a trough. So, I learned about a pressure system. It's a relative peak or lull in sea level pressure distribution. The surface pressure at sea level is minimally with the lowest value measured 87 kilopascals, and the highest recorded is 157, 108 and 57 kilopascals. High and low pressure system evolved due to interaction of temperature differential in the atmosphere, temperature difference between atmosphere and water within ocean and lakes. The influence of upper level disturbance as well the amount of solar heating regionalized cooling of area receives. And so I learned from a cool, also called a saddle point or neutral point. Is in meteorology the point of intersection of a trough and a ridge in the pressure pattern of a weather map. It takes form of a saddle where the air pressure is slightly higher than that low pressure region but lower than that of anticlonic zones. So we are moving here from the week 2. So I learned from a week 2 is as tropical cyclones and subtropical cyclones are named by various warnings centers to provide ease of communication between forecasters and the general public regarding forecast watches and warning. So, in the North Atlantic Ocean, tropical or subtropical cyclones are named by the National Hurricane Center or NHC RSMC Miami when they are judged to have intensified into a tropical storm with winds at least 34 knots or 39 miles per hour or 63 kilometers per hour. There are 6 lists of niche which rotate every 6 years that begin with the first letters A to W used escaping Q and U, alternating between male and female names. In the Eastern Pacific Ocean, there are 2 warning centers that assign 2 tropical cyclones, and on behalf of the World Meteorological Organization or WMO, when they are judged to have intensified into a tropical storm with winds at least 34 knots, 39 miles per hour, 63 kilometers per hour. So, when a tropical depression intensifies into a tropical storm to the north of the equator between the coastline of the Americas and 104 degrees west, it will be named by the NHC. So, within the South Indian Ocean, in the South Hemisphere within Africa and the 90 degrees east, a tropical or subtropical disturbance is named when it's judged to have intensified into a tropical storm wind at least 34 knots or 39 miles per hour or 63 kilometers per hour. So, in a South Atlantic Ocean, when a tropical or subtropical storm exists in South Atlantic Ocean, the Brazilian Navy Hydrographic Center's Marine Meteorological Service names the system of using predetermined list of names. The names are assigned to alphabetical order and used in rotating order without regard to a year. So, in the Southern Pacific Basin in the Southern Hemisphere between 160 degrees east and 122 degrees west, a tropical cyclone is named when observation or Dvorak NCT analysis indicate the system has a gale force or stronger winds center which are forecast to continue. So, we are moving here into week 3. So, I learned in week 3 is all about weather information and forecasting on shipboard. So, introduction. The seafarers have access to diverse documentation that can be caused in order to realize an overview of existing meteorological situation and estimated the future trend of the weather condition. So, I learned about in weather information and forecasting shipboard, there are several types of weather messages to broadcast by radio in most parts of the world. So, there are weather warnings, forecast messages, analysis and prognosis message, hypnotic messages. They add weather maps via radio fax mail received on shipboard and INMARSAT in Marsat, and also those who prepared ships based on direct observation made by seafarers. So, here's also the weather messages. Weather warnings and forecast messages are in plain language. Maritime for weather forecasts include four types of weather warnings: small craft, gale, storm, and hurricane force wind. The meaning of this warning are: small craft warning. It's the winds of 20 to 33 knots and the wave heights to 2 or 3 meters or 7 to 10 feet. So the gale warning, it winds are 34 to 47 knots. It's kind of strong. And the wave heights is 6 to 9 meters or 20 to 30 feet. Storm warning, winds it's 48 63 knots and wave heights it's 9 to 16 meters. Hurricane force warning, wind 64 and over the wave heights over 16 to 52 feet. So we are moving to the weather maps. The weather map is display various meteorological features across a particular area at a particular point in time and as a various symbols which all have specific meanings. Shots maps has been used since the mid-19th century and are used for research and weather forecasting purposes. Map using isotherms show temperature variance which can help locate weather front. Isotherms map analyzing lines of equal wind speed on a constant pressure surface of 300 MB or 200 MB show where jet stream is located. So, the forecasting techniques and methods. Forecasting techniques. The technique used with the surface analysis charts in the tracking the weather is based on the idea that past is indicator of future. A minimum of 2 surfaces analysis charts received each day is recommended, and more than it's when situation is rapidly changing or critical operation requiring the most up-to-date information are involved. Take the latest map and the one previous to it and plot the area location of the high and low centers or fonts. Plot this on latest charts. Based on the past movement between the two maps, project ahead by noting the position of these features at 12 and 24 hours into the future on the latest map. Another useful feature to advance in the region of closely spaced isobars in which gale force or stronger which are likely. So, we are moving here to the week 4. Week 4 is about the World Meteorological Organization. I learned about the World Meteorological Organization. So, first, the definition of the World Meteorological Organization. Standard meteorology reported starting nearly 150 years ago, long before the invention of the radio. Apart from reporting the weather by radio, which started in 1906, changes have been gradual. In 1946, all members of the British Commonwealth decided to cooperate in organizing meteorological work at sea. A year later, the WMO was formed and extended this operation to include all countries and introduced a universal code to standardize all weather reporting. Since then, only minor changes have been necessary. Today, there is a large number of voluntary reporting ships, divided into three groups: selected ships, voluntary ships, and auxiliary ships. Reporting the represent weather from the sea are the liners, tankers, container ships, tramps, fishing vessels, supply vessels, oil rigs, dedicated weather ships, automatic buoys, and lighthouses. Indeed, all types of vessels. The report are to vast amount of gathered area from weather satellites. Indeed, the biggest problem the forecaster is sorting all of the data available. Without computers, it would be impossible. The World Meteorology Organization consists of General Assembly each member nation, having one vote together with Secretariat and Technical Committee. The Technical Committee formulates rules for coordinating all weather reportings, dividing all the globe into areas. Is the responsibility of one member country as understanding the codes of organizing the sharing information between member states of the World Meteorological Organization Center. Assembly approves the works of the technical committee. So, resolutions are sent to member states of ratification and inclusion in statutory instrument making the rules legal for that state. Selected ships observe wind, weather, pressure, barometric tendency, temperatures, clouds, and waves. They are equipped with a precision unreal barometer, a barograph weight and dry bulb thermometers in a marine screen, and a sea thermometer and bucket. So, the coding of ships observation. As described above, governments of any nations, including UK, have through the World Meteorological Organization devised codes to unify all meteorological messages sent to and sent to and from shipping. You will be expected to use this code. Full details are given in the ship codes and the code book. So that's all I learned from week 1 to week 2, week 3, week 4 from the subject of meteorology 211. So that's all I learned from this final project.